All right, in this section, we are going to be talking about angles and lines. So first, we're just going to get a bunch of vocabulary words out there. We're going to talk about the vocabulary word, its definition, and then talk about, kind of show a diagram of what it would look like, as well as the symbols that we use to mathematically represent it. So the first vocabulary word is a point. And a point is just a location in space. It could be any point. We usually use just a little dot to represent a point, and we'll often label those points with capital letters, like A. Okay. The next word is a line. A line is a thing or a segment that extends forever in two directions. So it does have to extend forever. That's an important part of being a line. So a line would look something like this. We use these arrows on the end to denote the fact that it's continuing on forever and ever. And there's a couple different ways to name a line. We can name it with 2 points. And if we name it with 2 points, then we represent it like on paper as AB, so the 2 points with a little line symbol over it. We can also just name the line with a singular letter. So maybe we'll just name this line, line M. So we could also say that this line is just line M. The next vocab word is array. Array is part of a line that starts at a point and goes forever in the other direction. So you can kind of think of it as half of a line. So it would be like starting here at point A and then going forever. We're going to throw another point B on here too so that we can name the ray. So if I want to name the ray, I'm going to name it AB. So I'm going to use the 2 points that are defining the ray. And then I'm going to put a little line segment that has 1 arrow on it. And you want to make sure that since the line is going forever in the direction of B, that the little arrow goes over the B. Okay. The next is called a line segment, or sometimes we just call it a segment. And a line segment is just a portion of a line with 2 endpoints. So it'd be like just having kind of a chunk of a line with AB. And the way that we define or write that line segment, we just write AB with the horizontal line over the 2 points that are defining the segment. All right, the next one is a plane. A plane is just a flat surface that extends forever. I'm actually not going to draw anything in the diagram and symbols box because that box itself represents a plane. It's just a blank or a flat surface that extends forever. And you can put anything you want in a plane. You could put points or lines or line segments or rays into a plane. It's kind of like your blank canvas that you're starting with. So these are kind of our building blocks, and we're going to use points, lines, rays, and line segments to create angles and shapes and other relationships. So the first thing we're going to talk about is an angle. So an angle is basically taking 2 rays and putting them together so they share an endpoint. So the 2 rays are going to be called the sides, and the endpoint is called the vertex. So let's take a look at what that will be. So I'm going to have 1 ray. I'll label that point right there B, and then another ray. And that is an angle. So I have 2 rays, and they share that endpoint of B. Now there's lots of different ways to name this angle. One, you can just name it B. And we put this little symbol in front of it. It's like a little angle symbol. And that just means that represents angle B, where B is the vertex. Or sometimes we'll put a little number inside here. Like we'll say this is angle 2. So you could say this is angle 2. Or if you have more points, like let's say this angle, on the other sides of the rays we have those points A, B, C. We could say this is angle ABC. Okay. And an important thing to do if you're going to name your angle using 3 points like this, so you have to go in order. You've got to go ABC or CBA, but you couldn't go BAC. Okay, that middle letter has to be the vertex of the angle. So lots of times with angles, what we care about is how open are they? And what we're going to do, what we use to talk about that is the angle measure. And the angle measure just tells us how wide the opening of an angle is. And we're going to give this answer in degrees. Okay. So let's say I have some angle. We'll just call it angle A. And I want to know how open, or what the openness is of angle A. Then I'm going to put a little m in front. That means what's the measure of angle A? And the measure of angle A is equal to, let's just say it's equal to 30 degrees. That's just an example of how you would denote angle measure. Okay, so the next vocabulary word is a descriptor word, and it describes two segments that are the same length. We would call these segments congruent. Okay, so let's just say I have two segments. We'll call them A, B, and try to make them look the same length, C, D. So those two segments are the same length, then we would say that they're congruent. And the way that we would write that is we would write AB is congruent, so it's like an equal sign with a little squiggly on top, is congruent to CD. And that tells me that those segments are exactly the same length. If you wanted to note congruence on the picture, what you would do is you would put these little tick marks on them. So if those line segments both have one tick mark, that means they're the same length. If you had multiple segments that were the same length or that were congruent, then you would just start adding two tick marks. So like two tick marks on both segments means that those two segments are the same length. Okay, we can do the same thing with angles. If we have two angles that are the same measure, they're going to be congruent angles. So the way that would look is we would have two angles. Maybe we have angle A, and then we have over here angle B. Oops. And you can use any letters to denote these. We usually use capital letters. That's kind of your one rule that you're going to want to stick to. And if we want to say these angles are congruent, we would say that angle A is congruent to angle B. And then if we wanted to show that on the picture, we would use these little angle measures. Okay, so we would say if they both have that one little kind of curved half circle in the angle, those are congruent. Or if maybe we want to say, okay, we're going to label these with 3. Any angle that has the 3 little curved lines means that they're all congruent. So angle measures are really interesting, and we tend to ask a lot of questions about them. So we're going to start by classifying some angles, all of our angles, into 4 different groups. The first group is acute angles. And acute angles are any angles that are between 0 degrees and 90 degrees. So anything that is an angle that's between 0 and 90 degrees. The next is what happens when you have an exactly 90-degree angle. That is called a right angle. And we often denote our right angles with this little square. If you see a square in an angle, then it means it's a right angle and it measures exactly 90 degrees. An obtuse angle measures between 90 degrees and 180 degrees. So remember, 90 degrees is like your right angle, and then 180 degrees would be a straight line. So an obtuse angle just means that it's kind of like a wide angle. Okay. And then our last option for this section is that you could have an angle that measures exactly 180 degrees, and that would just look like a straight line. Okay, it's kind of weird to even think about it as an angle, but it would just be a straight line. Okay. So let's talk some more about angles and why we should care about them, and just some cool things about them. So one thing that comes up a lot is we tend to see angles whose measures add up to 90 degrees. These angles are called complementary angles. So if I say two angles are complementary, it means that if you add up their measurements, you're going to get 90 degrees. So let's say I have this angle, let's make it angle S, and then I have this other angle, We'll make it angle T. And let's say those are complementary. That would mean that if I take the measure of angle T and add it to the measure of angle S, I'm going to get 90 degrees. Maybe that means that angle T is 40 degrees and angle S is 50 degrees, so I add up to 90 degrees. Either way, the two angle measures in degrees have to add up to 90 degrees. Our next vocab word is really similar. It's what happens when the angle measures add up to 180 degrees, or to a straight line. Those are called supplementary. Okay, so supplementary angles would be something that adds up to 180 degrees. So let's just say I have angle A here, and then I have angle B here. And if those are supplementary, it means that the measure of angle A plus the measure of angle B is equal to 180 degrees. Okay. The next few angle terms, the next few vocabulary words, have to deal with angles and their relationship and location to each other. So if you have two angles that are next door to each other and they share a side, that's going to be called adjacent angles. And let's look at a picture of that. So adjacent angles just means that if you've got one angle like this, and then you have another one down here, these two angles would be adjacent angles because they're right next to each other. Okay, they share one side. They share that middle piece. Okay. The next is a word that we use to describe two angles that add up to a straight line. So this is important because it's kind of like complementary, or it's kind of like supplementary, but they have to be on the same line. So a linear pair just means basically you've got a straight line and you've kind of chopped that straight line into two different angles. Okay, so you've got, let's go ahead and label this. So you've got like angle ABC and angle CBD. Whoops, that's a C. CBD. Okay, those would be two angles that form a linear pair. It just means that when you put them together, when they are together, they form a straight line. And this next box is actually just a theorem. So this is kind of just an important thing to know. So I'm just going to put a star in it. The angles in a linear pair are supplementary. So if two angles form a straight line, it means that when you add them up, they're going to add up to 180 degrees. So all angles that are linear pairs are supplementary, but not all supplementary angles are linear pairs. Okay. The next vocabulary word is called a vertical angle. Okay, a vertical angle, or vertical angles rather, are angles that are across from each other. So in this case, we're going to have two different lines. And vertical angles are angles that are across from each other at the intersection. So these two red angles that I'm highlighting, those are vertical angles. And the next box, the next line has something really important. It's another important theorem. Vertical angles are congruent. So anytime you can find a pair of vertical angles, you know they're congruent, which means that their angle measures are the same. Okay, so we've talked a lot about angles and the relationship between angles and some vocabulary words to use there. Let's talk about some relationship between lines. So, parallel lines. Okay, parallel lines that are equally distant apart and they never intersect. So they never touch each other. So let's just say I have these two lines and they're parallel to each other. Let's go ahead and name those lines M and N. So I can show you that the symbols we use to denote parallelity, to denote that these two lines are parallel, is that you would say M is parallel to N. So that little double vertical bar tells you that they're parallel. If you want to denote on the picture that they're parallel, you put these little kind of arrow symbols in the middle of the line. And that means that those two lines are parallel. You could also do like 2 little arrow marks if you need to. Okay, the other important relationship between lines and line segments is perpendicular. So perpendicular lines are lines that intersect to form 4 right angles. So you basically have something like this, and then all of these angles inside that are formed here are all right angles. Let's go ahead and show you the symbol to show perpendicularness. So we would say M is perpendicular to N. So that kind of upside down T, that means that the 2 lines that are before and after the symbol are perpendicular to each other. Okay, that's all the vocabulary words. So basically what we gain from those vocabulary words is, one, a way to talk about geometry and angles and line segments and points in a way that we can all agree on. So when I say angle ABC, you know what I'm talking about. It also gives us some information. So we learned, for example, that vertical angles are congruent. So now when we see vertical angles, we can call them congruent. So let's just do a couple examples of using these vocabulary words. So in the first one, we're going to name this angle in as many ways as we can. So one, we can name it just by saying that's angle 1. We could also say that's angle C and just name it by the vertex. Or we can name it by the points. So we could say that's angle BCD. So B, then C, then D, and it kind of tells you what order to go in. We could also name it angle ACD, or we could name it angle BCE, or we could name it ACE. Okay. The important things when you're naming an angle with 3 different points is that your middle letter always needs to be the vertex. And then the letter on either side needs to be 1 letter from each side, from each of the rays, right? So we kind of went from the top ray down to the bottom ray. You could also do the opposite. You could say this is angle DCB and kind of start from the bottom and work your way up. You could also have angle DCA, angle ECB, or angle ECA. Okay. One thing to just be cautious of is that you're really making sure you get the order of these angles right, and that you put the angle sign. If you don't put the angle sign in front of your the way you're naming the angle, I don't know it's an angle. I don't know if you're just saying this is 1, or this is point C, or this is just some random list of letters. You've got to make sure you put that angle sign in there. Okay. So now let's talk about this picture down here in B. We are going to list all of the information that this diagram gives us. So we'll just start with some of it, and we'll hopefully be able to get through all of it. I'm going to start with these congruent angles. So if you look at angle DBA, so this angle right here, and angle ACE, those angles both have a double, kind of like a rainbow, a double angle symbol. That means they're congruent. So I'm going to say angle DBA is congruent to angle ECA. And here, the order that I went in was actually important. So I started kind of on the outside working in with DBA. So I'm going to do the same thing with the ECA angle and kind of work in a outwards working in way. Okay. So we know those 2 angles are congruent. We also know another pair of congruent angles would be angle ABC is congruent to angle ACB. So that kind of gives you these interior angles right here of the triangle. So I want to just talk for a second really fast about these 2 angles that are congruent. It was really important that I didn't just say angle B is congruent to angle C. Because if you look at this picture, angle B at point B, there's two different angles. So if there's two different angles happening, like if B is the vertex of two different angles, then you need to denote it using the 3 points so that I know which angle you're talking about, so I know which angle is congruent. Okay, let's do one more thing with the angles. There's actually one other set of angles that we know are congruent, and it's kind of a hidden angle. But if you think about this angle over here at angle B, it's kind of adding up these two angles, which is going to be the same angle that's happening over here on this other side. So like the bigger angle at B and the bigger angle at C are also congruent. So the way I would denote that is I would say angle DBC is congruent to angle ECB. Okay. So there's 3 sets of angles that we know are congruent to each other. So let's go ahead and take a look at some line segments. Okay. We know from these tick marks that are here that AB is congruent to AC. So we'll write line segment AB, and remember having just the one line over it means it's a segment, is congruent to AC. Okay. Now there are a lot of other things in this picture that might look like they're congruent. Like it kind of looks like these two line segments like DB and EC are congruent. But since it's not telling us that they are, we can't assume that they are. So we couldn't say DB is congruent to EC as much as they look the same. So that's one thing that's really important to do when you're looking at shapes and pictures and geometry, is you can't assume anything. Okay? You need to only rely on what they've told you is actually true. Okay, and that is just a brief snapshot at some of the vocabulary that we're going to be using throughout the rest of this unit.